Hi there, Mrs. Pesic here. This is a quick little refresher on direct variation. This would go along with your summer algebra review pack section 2.5. So we are modeling direct variation in this section. And first thing you need to know is that any direct variation equation is always going to be of the form y equals a times x, all right, where a is just some number. That equation represents direct variation between x and y, and we could also say that y varies directly with x. Notice that the y-intercept is 0. It's not ax plus 3 or ax plus 2 or anything like that. It's just ax, so the y-intercept is always 0. All right, that means that all direct variation graphs will go through 0, 0. Some examples of direct variation graphs, I'm sorry, of direct variation equations might be something like y equals 3x, or y equals negative 2/3 x, or you might even see it as y over x equaling 9, something like that. Those would all be examples of direct variation equations. All right, the non-zero constant a is called the constant of variation, and that really is your slope. The graph of a direct variation equation, y equals ax, has a slope of a. All right, so with this example, you're going to write and graph a direct variation equation that has 6, negative 2 as a solution. So what I would suggest is that you start off with your equation, y equals a times x, and I would plug in the x value. So if I plug in negative 2 for y and 6 for x, I end up getting, let's see, if I divide both sides by 6 to solve for a, I end up getting a equaling negative 2/6, or the same thing as negative 1/3. Now that's not our equation. Our equation has to have y and x in it. So we need to plug this negative 1/3 right in here for the a. And so our equation is going to be y equals negative 1/3 x. So there's our equation. And then if we're going to sketch a graph of that, let me pop that on another page. We're graphing the equation y equals negative 1/3 x. I know it goes through 0, 0, so I can put that y-intercept right there. And I have a slope of negative 1/3. So it goes down 1 to the right 3, down 1 to the right 3, and so on, or up 1 to the left 3. And so my equation, the graph would look like this. All right. All right, so that's that example. And let's see, was there another example we were going to look at on this page? Yes, let's look at this example. This one says the variables x and y vary directly, and x equals 10 when y equals 4. Write an equation that relates x and y, and then find y when x equals 8. Again, as soon as you see that x and y vary directly, that is your clue. Those are your key words that you should be focusing in on to write down y equals a times x. All right, in this case, they're telling you what a is, or what x is, and what y is. So let's plug in 4 for y and 10 for x. At this point, we need to solve for a. So let's divide both sides by 10. And we get a equaling 4/10, which is 2/5. And so that means that we can write our equation with plugging in the 2/5 right here. We would get y equals 2/5 x. So that is our answer for part A. And now we're supposed to find y when x equals 8. So for part B, you would just plug in 8 for x right here. So we would have y equals 2/5 times 8. So that's going to be 16/5. And that would be your answer. So y equals 16/5, which is 3 1/5. So that could be your answer for part B. All right, and the last example that I wanted to show you is to use ratios to identify direct variation. Let's take a look at this example about sharks. Great white sharks have triangular teeth. The table below gives the length of a side of a tooth and the body length for each of 6 great white sharks. Tell whether tooth length and body length show direct variation, and if so, write an equation that relates the quantities. Okay, so the first thing to do is to look at your data. There's really 2 things that you need to check to find out whether this is going to be direct variation or not. First thing is, the idea with direct variation is as one variable goes up, the other one goes up. All right, that's the first clue. All right, so is that true that as the tooth length goes up, and they have them nicely in order for you, 1.8, 2.4, 2.9, 3.6, so we can see that the tooth length is going up. Is it true that the body length is going up? It is true. All right, that does look like the body length is going up. So that's the first thing to check. But just because that is true doesn't mean that it's necessarily direct variation. So the second thing you have to do is you need to make sure that your ratio of y over x is some constant. Remember, that's going to be our a. That this equation right here comes from this equation that we're used to. All right, just divide both sides by x and you'll get this equation. So is it true that the y coordinate divided by the x coordinate is going to be the same or very close for all of these? So is 215 over 1.8 the same as 290 divided by 2.4? And is that pretty close to 350 divided by 2.9, and so on? And they're showing you here all those ratios, and they're all right around 120. This is real life data, so it's not going to be precise, and that's okay, but they're all really close. So that's why your final answer could be that your body length, B, is going to be equal to 120 times the tooth length. All right, in other words, this value here is your A value that you would plug in. All right, and so really it's right around 120. So A is approximately, that double squiggle means approximately 120. And so our answer here would be y equals 120x. Or if we use B for body length and T for tooth length, B is equal to 120 times T. All right, and that concludes this little refresher video. I hope that was helpful. And if hopefully you will be checking out some of the other refresher videos before the test on your summer review algebra packet. All right, have a great day.